Captions. In our last video, we saw that as long as we have an equation in two variables, x and y, where y is by itself, then we can draw the picture of all of the ordered pairs that make the equation true by substituting in many different x values into the equation to create a table of values. And then if we're lucky, the numbers that we have chosen for x turn out to be numbers that are going to show the important part of what the picture looks like. Now, since we just started, we don't know what the important x values are going to be when we see an equation that we're trying to graph. But if y is all by itself, if we don't know where to start, we can at least start with numbers close to the origin. And if we're lucky, we will see the important parts of the picture. In this example that we did in the previous video, the picture sort of had a U shape. And then we looked at another equation that the picture, the graph of its solutions had sort of a V shape or a check mark shape. Most of the equations that we are going to see from here on out are going, in this course, are going to have pictures that actually form a straight line. And here is one example, but I sort of gave away the punchline already, that this picture is going to turn out to be a straight line. But let's look at a table of values. Let's create a table of values and draw the picture and see why. So again, I have chosen, in this case, it looks like 10 different x values to substitute in to our equation. I've picked integers to make the arithmetic easier. And the first one is x is -3. So when x is -3, two times -3 is -6. -6 minus 3 is the same thing as -6 plus -3. So that's -9. And again, as we mentioned in the previous video, doing the same sort of arithmetic over and over and over again, just with different numbers, gets a little tedious. And so eventually, we want to figure out a way to maybe not need to evaluate and find several ordered pairs that make an equation true, maybe there's a way to know ahead of time what are the smart X values we need to choose, etc. Zero minus 3 is the same as 0 plus negative 3. So when X is 0, Y is negative 3. When X is 1, we get 2 minus 3. 2 plus negative 3 is negative 1. When X is 2, 2 times 2 is going to be 4. 4 minus 3 is 1. When X is 3, if Y equals 2 times X minus 3, two times 3 is 6. 6 minus 3 is 3. When X is 4, two times 4 is 8. 8 minus 3 is 5. When X is 5, take out X, replace it with 5. 2 times 5 is 10. 10 minus 3 is 7. And when X is 6, we get 12 minus 3, which is 9. As in the previous two examples, I used a computer sorry about that. As in the previous example, I used a computer to help me create an even larger list of ordered pairs that make this equation true. And again, there's nothing that's preventing me from saying, well, what happens when X is 300? Or what happens when X is 6.5? Or what happens when X is negative 4.3? Right? We can substitute in any X value we want, and we can find the corresponding Y value. So as before, I have copied that table of values on this page, and now let's look at the picture. And if it helps, we can label the origin. It might help to make the labeled numbers on the axes to put tick marks there to make it easier to count. When X is -10, Y is -23. So that would be way down below my picture. I'm not going to be able to draw that. If I had a whole piece of paper that was a graph paper, I could count down 23 units, but the piece of graph paper I was given only goes down to -10. So I would just be estimating. So when X is -3, Y is -9. So that would be here. And when X is -4, Y is -9. So to the left, I mean, -11. So to the left 4 and down 11, that would be somewhere about there. That one we can sort of visually estimate okay. But even the next one, -5, -13, that's getting harder to visually estimate where that would be. So now -2 for X, so that's to the left 2, and -7 for Y, that's there. Then when X is -1, Y was -5, so to the left 1, down 5. When X is 0, Y is -3, so don't go to the right, but go down 3. When X is 1, Y is -1. When X is 2, Y is +1. When X is 3, Y is also 3. When X is 4, Y is 5. When X is 5, Y is 7. When X is 6, Y is 9. So to the right 6, up 9. And when Y is 7, when X is 7, Y is 11. So that would be off the paper. And at least between X being -3 and X being 6, all of these points are on a straight line. So the question now is, does the picture continue like this forever? Or not? And in this particular case, the answer is yes, it does. But notice in one of the problems in the previous video, there were a whole bunch of points that were on the same straight line segment, but then all of a sudden the graph turned and went in a different direction. So we don't really know whether or not that might happen in this picture, because it's only our third example of graphing an equation. So does it continue forever on a straight line, or does it turn somewhere? We don't really know yet, but I'm going to tell you that yes, in this case, it really does continue as a straight line forever. And when that happens, then the graph, we say the graph is linear, it's a line, But we also say that the equation is a linear equation. So in our previous two examples, neither this picture nor that equation, they are not linear equations. The graph is not a straight line. And this equation is not a linear equation because its graph, the graph of its solutions, is not a straight line. So it would be nice to know ahead of time which equations have graphs that are in fact a straight line. And we're going to skip that problem for now. We're going to go to this one. Without explaining exactly why, I'm just telling you that any equation that can be written as a number times x plus a number times y equals a number, it is a linear equation. Its picture will be a straight line. And this, when the equation looks exactly like this, we say that the equation is in standard form of a line. So notice that x and y are in separate terms. X and y are not in the denominator of a fraction. X is to the first power. Y is to the first power. We do not see x inside an absolute value, nor y inside an absolute value. We do not see x underneath a square root sign, or y underneath a square root sign. We do not see 1 over x. We do not see 1 over y. We do not see x to the second power or x to the third power. We don't see y to the second power or y to the third power. we don't see X times Y anywhere. They're in separate terms. So now if we go back and look at the two examples from the previous video, in problem 2 from the previous video, we have an X to the second, not just X to the first. That's a clue to us that the picture is not a straight line. Or in the third example from the previous video, we had X inside an absolute value. It was actually X plus 2 was inside the absolute value. But the important thing is that there was a variable inside an absolute value. That tells us now that the graph of the solutions to this equation, the picture of the ordered pairs that make the equation true, is not going to be a straight line. But the problem that we looked at earlier in this video, we have one term with X, we have one term with Y, and we have a constant term. These two terms are not in, I mean, this equation is not in standard form, which is a number times X plus a number times Y equals a number. But we could get it to look like this. So in particular, we had this equation on the previous example. Notice that we could add 3 to both sides. Then we would have Y plus 3 equals 2X. And we could subtract Y from both sides, and we would have 3 equals 2X minus Y. And then we could exchange the left and the right-hand sides. And we could change our subtraction into adding the opposite. And we could change Y into 1Y. And so now our equation looks like a number times X plus a number times Y equals a number. So capital A, capital B, and capital C are numbers, and X and Y are variables. So suppose we look at this equation, 5X minus 3Y equals 0. We could rewrite that as 5X plus negative 3Y equals 30. And so now that looks like a number times X plus a number times Y equals a number. And so the graph of the solutions of the equation 5x minus 3y equals 30 will be a line. We know that now because it has a term with x, a term with y, and a constant term. Now, from geometry, we know that you can pick any 2 points and there's exactly one line through those 2 points. And if we have 3 points, they might be collinear. They might all lie on the same straight line. Drawing my picture freehand, I missed a little. There we go. But it's possible that when you have 3 points, you don't get a line. They're not collinear. And they could be the vertices of a triangle. So when you have 3 points, they might be collinear or they might not be collinear. But if you just have 2 points, of course they are collinear. Of course there's one line that goes through them. So from now on, if we know we have a linear equation, we only need to graph 3 points. And if they line up, then we know our picture is correct. So in this equation, the y is not by itself, but because x and y are in separate terms, they're both in the numerator, they're both to the first power. Not only do we know that the graph is going to be a straight line, we also know that if we can pick a number for x, we can calculate the corresponding number for y by using algebra. So we can pick any 3 different x values. Often we pick a positive, a negative, and 0. You don't have to, pick a positive, a negative, and 0. You can pick any 3 points, but usually we do. The picture will be more accurate because as humans, we can not draw things perfectly. The picture will be more accurate if our X values are spread out. In other words, not too close to each other. Many people like to start by choosing 0 for X. So let's pick X equal to 0. Our equation is 5X minus 3Y equals 30. Once we substitute a number for X, now our equation only has Y in it, and we will be able to solve this equation for Y. 5 times 0 is 5. Subtracting 3Y is adding negative 3Y. We can subtract 5 from both sides. We get negative 3Y is 25. And then we can divide both sides by negative 3. And we get Y is 25 divided by negative 3. We don't like fractions with negatives in the denominator. So that's the same as negative 25 divided by positive 3. And in order to graph a fraction, if it's improper, we need to make it a mixed number. So this is going to be the negative of the mixed number. Well, 3 times 8 is 24. So this is 8 1/3, the negative of 8 1/3. Oh, I messed up, didn't I? Let's pretend I didn't notice that I messed up. 5 times 0 is 0, not 5. Actually, I am going to fix it now for a different reason. So 5 times 0 is 0, and 0 plus negative 3y is negative 3y. And now if we divide by negative 3, we get an integer, y is negative 10. So if we were to, so now we can put negative 10 in our table of values. And when we go to graph that point, again, we might want to highlight some of the marked values on the 2 number lines. If X is 0 and Y is negative 10, that's all the way down here. And that's as big as our graph paper gets. So if in fact this is a straight line, the straight line might look something like this, or it could look something like that. But in either case, part of the graph is going to be below what we can show on our picture. So even though usually or often we pick a positive, a negative, and 0, in this particular case, we're either going to need to pick 2 positives or 2 negatives, and we won't know until we do. So I'm going to just pick a positive number. I'm going to pick x equal to 9. You can pick any number you want. I'm going to use a different color just so we can see it when we graph it. So 5x minus 3y equals 30. 5 times 9 minus 3y equals 30. So 45 plus negative 3y equals 30. The 45 is positive, so I'm going to subtract that from both sides. And I get negative 3y equals negative 15. And I happened to pick a convenient x value that when I divide negative 15 by negative 3, I get an integer. But you're not always going to get an integer. When I had made my mistake over here before, notice I had a mixed number. So what we have just decided is that when x is 9, y is 5. So 9, 5 is there. So I probably don't want to pick a negative number now for x because my line is going to be down here, assuming that I graphed both of these correctly. Maybe I'll pick another positive x value. Maybe I'll pick x is 4. If x is 4, then my equation is 5 times 4 plus negative 3y equals 30. So 20 plus negative 3y equals 30. We'll subtract 20 from both sides. Negative 3y is positive 10. This time when I divide, I'm not going to get an integer. I have y is 10 over negative 3, which that's the same as negative 10 over positive 3. That's an improper fraction. It's a negative of the mixed number 3 1/3. 3 times 3 is 9, and there would be one more left over to make it to 10. So when x is 4, y is negative 3 1/3. So from the origin, in the x direction, I go to positive 4. In the y direction, I go to negative 1, negative 2, negative 3. And then I go 1/3 of the way from negative 3 to negative 4. So that would be about there. So now I should be able to use a note card or a ruler or the edge of a notebook or even a piece of paper that has a nice crisp fold. And these 3 points should be collinear. I know they have to be collinear because this equation is a linear equation because it looks like a number times x plus a number times y equals a number. So I'm going to use my straight edge and I'm going to line up the 2 points that are farthest apart, and I'm going to draw that line. And when I draw that line, it should go right through the point that's in between them. If it doesn't, I made a mistake. Remember when I first made my mistake over here and I wrote 5 here instead of 0, the corresponding value for y that I got was -8 1/3. That would have been here. Notice that if I try to draw a straight line from this orange point to my green one, if I draw that line, it completely misses this point. And that would tell me that I made a mistake somewhere. Right? When I had 0, -8 1/3. So if my 3 points form a triangle instead of a straight line, but I know my equation is linear, then I know that I have made a mistake. It doesn't tell me where I made my mistake. It could have been from the very first thing I did to the very last thing I did to actually plotting the points. I could have actually gone backwards and interchanged x and y for one of my points. In my case, the mistake that I had made was that I had written 5 here, thinking 5 times 1 instead of 5 times 0 for some reason. Brains are funny that way. But I would have known that something was wrong. Okay, let's try another example. This equation already looks like a number times x to the first power plus a number times y to the first power is equal to a number. So this equation is a linear equation. And so its graph will be a line. And therefore, we need only 3 points, not 9 points, not 29 points, not 900 points. We only need 3 ordered pairs that make the equation true. Again, on this particular graph paper, it only goes from -10 to +10 in both directions. If we print out a whole sheet of graph paper, we can count easily to like -30 and +30 in both directions, even when we're counting by 1. Oftentimes, we pick a positive, a negative, and 0. A lot of times we start with picking 0 for X. We get to choose. We could pick X equals 100 if we want to, but we won't be able to show it on this picture. So pick X equals 0. So if 2X plus 4Y is 30, then if X is 0, let's see if I can multiply by 0 correctly this time. 2 times 0 is 0. 0 plus 4Y is equal to 30. 0 plus 4Y is 4Y. This time I'm going to divide both sides by 4. I don't get an integer when I divide, but I do get a nice decimal this time, a nice terminating decimal. So you could write your answer as a terminating decimal. You could write the result as a simplified fraction, and then you could write that fraction in as a mixed number. But we get a nice terminating decimal, so let's just go ahead and write Y is 7.5. That would be 7.5. Notice that 4 times 7 is 28, and there would be 2 left over. So that would be 7 and 2/4. And 2/4 is 1/2, and 5/10 is 1/2. So that makes sense that the decimal is 7.5. So 0, 7.5 would be, there's 7, 7.5 would be there. Okay. Again, this point is almost, but not, it's almost to the edge of this graph. So we might want to, we may be unlucky the next number that we pick. Some people will just always pick X equals 0, and then for their second one, they'll always pick X equals 10, and for their third one, they'll maybe pick X equals -10. Or maybe they'll always pick 5 and -5 or something like that. That's fine. Let's see what happens if we pick X equals 10. Two X plus 4Y equals 30. If X is 10, 2 times 10 is 20. And we're going to be subtracting that from 30. So we get 4 times Y is 10. And again, the nice thing about dividing by 4 is you always get a terminating decimal if you don't get an integer. So we get positive 2.5 this time. So 1, 2.5. So if my two answers are correct, if I do pick a negative number, I probably don't want to pick -10 because I think my line will be way up here somewhere. So I might pick a smaller negative number, a negative number relatively close to 0. Let's see. Maybe let's see what happens if we pick -2. So 2x plus 4y is 30. 2 times -2 is -4. Because that's negative, we're going to add 4 to both sides. So 4y is 34. And if we divide both sides by 4, we get this time 8.5. So when x is -2, y is 8.5. So now I'm going to use my ruler, my straight edge, and I'm going to line up the 2 points that are farthest apart. And I'm going to draw the line that goes through, in this case, my purple point and my green point. And the pink one should be on that straight line. And it is. And I have a very high confidence that all of my work is correct. And as long as you write this table of values, you don't necessarily, for my purposes, have to write the coordinates over here on the picture itself. You can if you want to. But I wouldn't, once you figure out these 3 things, I would then write this table of values, not just leave it, just this part down here, show the table of values, then graph the 3 points and the line. Here is another example. Again, subtracting 4y is the same thing as adding -4y. So our picture looks like a number times x. I mean, our equation looks like a number times x plus a number times y equals a number. So it is linear. And so we need only 3 points. If we go all the way back to this example from the previous video, if we graphed only 3 points, we would not understand that this picture is U-shaped. Since this equation is not linear, we have to graph many ordered pairs that make it true. How many? We don't know. In this particular case, we were able to graph these 9 ordered pairs And that suggests to us at least what the picture looks like close to the origin. But we don't know what this picture looks like when, say, X is 100 or when X is negative 250. Okay, so let's get back to this example now. So we might as well pick 0 for X. (3x minus 4y is 25). If X is 0, then we've got 0 plus negative 4y. Subtracting positive 4y is adding negative 4y. So we've got negative 4y is 25. We're going to divide both sides by negative 4. Again, because we're dividing by a 4, we get a nice decimal. We get negative 6.25, or negative 6 1/4. So the origin is where the two number lines meet. There's already, some of the numbers on both number lines have already been labeled for us. If they weren't, we would need to put the labels, the scale, we say, on the two number lines. All of the numbers in this problem are relatively small, so we might as well count by 1 in both directions. When X is 0 and Y is negative 6 1/4, so a little bit more negative than negative 6, between negative 6 and negative 7. All right. We could pick any positive number. I'm going to choose to pick 8 this time. I could pick 10. I could pick any number I want. (3x minus 4y equals 25). So if I substitute 8 for X, that gives me 24 plus negative 4y is 25. The 24 is positive, so I'm going to subtract 24 from both sides. And I get negative 4y equals 1. And so if I divide both sides by negative 4, I get negative 1/4, which is negative 0.25. So you could write the answer either way. So when X is 8, Y is just a little bit negative. Let's see what happens. Suppose I pick negative 5 for X. I'll write this down here. So 3x minus 4y is 25. I'm going to take out the x, replace it with -5. That's -15. -15 minus 4y is the same thing as -15 plus -4y. This time, since the 15 is negative, I'm going to add 15 to both sides. So I get 0 plus -4y. So that's -4y is, 40 this time. That's convenient. Because when I divide both sides by -4, I get y is an integer this time. I get y is -10. So when x is -5, y is -10. And again, I'm going to use this, in my case, this purple point and this green point. And I'm going to line them up with the straight edge of a ruler or a note card. And sorry about that. I just knocked something off my desk here. When I draw my line should go right through the point in the middle. My line, I missed a little bit on my green point. But I think that's close enough. So the moral of the story is the graph of the solutions to the equation that has the form a number times x plus a number times y equals a number, is a straight line, and we need only 3 ordered pairs that make the equation true in order to draw its graph relatively accurately and completely. Good luck, and we'll see you on the next video.